First, just thanks for everyone coming. It's great to see, I think Charlotte said 160, 170 people. So I think if we looked at smart metering a few years ago, maybe we wouldn't have got so many people in the room. So it's good. And old faces and new faces, which is a good mix, proves that new people are coming and the old people are still bothering. So I think it's a good mix of people. So I'm going to talk a little bit about what we do at the university that aligns to smart meters. I'm going to talk about some of the facilities, the main one being the Smart Meter Research Lab. And I'm going to talk to you a little bit about things we're going to do in the future as well. Okay, so without further ado, so Will leads the Applied Buildings Energy Research Group, of which I'm a member, and along with another kind of 11, 12 academics. We look at the building physics, we look at the built environment, and we look at social sciences. Okay, our main piece of work is building physics, as you would imagine, and that revolves a lot around the energy house, a lot around field trials, and it will revolve more or less entirely around Energy House 2 in the not too distant future. So we have 3 facilities. Okay, so working from the bottom to the top, we have Energy House, which is just over the road in Cockcroft. Some of you may have seen, others may not. We have the Smart Meters Lab, which is just over the A6, which is where the traffic jam is that probably most of you were sat in earlier this morning. And we have the Energy House 2. Energy House 2, I'm not going to labour, but we've got the money is in the bank, the tender is out now for the build, and we hope to be taken out of the ground very late on in this year, I think. So, you know, that's going to be the centre of what we do, but until then, and even from then, we kind of carry on with the things around Energy House 1 and the Smart Meters Lab. So, the Energy House is a building physics test laboratory, in essence. It's 2 terraced buildings in an environmental chamber. So we can adjust the temperature, -12, +30, put wind, rain, sun, and snow onto the building as well. So that's a very good test bed for measuring the energy performance of different things we can do to buildings. A lot of our work in the last, I think I'd say 2 years, has been around smart meters and smart controls in the Energy House itself. And maybe even going back about 3 meters from a time, 3 meters on the mind, 3 years from now when we started kind of tinkering around with them, I guess. We've got SMETS 1, SMETS 2 meters in there. We've got CADs and IHDs and gateways and stuff that we can talk to and draw information out of. We have Trilliant and Secure head ends, which these companies have very, very kindly provided access to. And we have our normal kind of dumb meters in there as well to make some kind of comparison about how they work and things like this. And we make extensive use of the ways of drawing out the data through APIs. And we change tariffs and everything else you can do through smart meters, we kind of dabble within there. So that's been useful for several projects. So also kind of added around that system that we have in there, we've got some ancillary equipment that form some typical smart homes in the UK. So solar PV, we have the broadband system, which is, kind of hooks all the smart stuff together, EV charging point, and bi-directional charging as well, which is it's quite interesting, which I'll come round to later on, and manage batteries and things like this. So we have a kind of full, I don't know, smart meter ecosystem in Energy House 1 as it stands. What do we do with all this data? We form part of the International Energy Agency, Annex 71. So I lead a group on this, looking at how we evolve energy performance figures for domestic buildings from using smart meter data and other kind of light touch data, so thermostats, small temperature sensors, etc. So that's an interesting program of work. We're in our 2nd year of that. We develop algorithms for energy forecasting in domestic buildings. We do a lot of model validation work. So, you know, a lot of people have an interest in energy modeling of building, as do we, but we like to validate our models and make sure they're right. And so that takes a lot of our time up. and live performance indicators. So think of it as a kind of live energy performance certificate for buildings that constantly changes with weather, with occupancy, with systems. So that's the kind of work that we're working on in the Energy House. So we decided that the Energy House is very busy. Okay, we've been booked up, I think it's more or less safe to say, every day since we first opened, and probably about 6 or 7 months out into the future from here as well. So we're very busy. So all our smart meter equipment was tied up a lot of the time. And we found our feet with smart meters, and we decided we kind of wanted to push it on a little bit, and a little bit more around the smart homes and how we can intersect smart homes with smart meters. So we thought that we pride ourselves really on engaging with industry, and I think the number of industry people in the room is kind of evidence of that. So we tend not to do anything without asking industry if we should do it or not, because that would be very academic if we didn't. So we put together a briefing paper with Jeremy, actually, from BEMA, who's somewhere in the room. There he is. And we kind of put a question to industry. How do we get customers connected to their energy data? And all the slides you've seen earlier on this morning, it's very easy. But we know there might be some small glitches in the system. So we posed this question. How do we get them interested in it? How do we get them connected to it? And what can they do with it? And Jeremy, who works with BEMA, was very kind enough to help us organise a meeting of industry and like-minded individuals. And this paper, pardon me, is available on our website and BEMA's website as well. So we had a roundtable meeting. We had a face-to-face, and we had a good chat, bit of an argument, and some heated discussion with suppliers, meter manufacturers, CAD manufacturers, BAYS, Innovate UK, all of the acronyms that we all love and know along the bottom. And I think we found there was a clear requirement to do some more stuff, whether that's use cases, whether it's technical demonstrations, and certainly some research and guidance for industry. And one of the outcomes of that meeting is why we're all sat here, to kind of get people together, and hopefully we might all know something a little bit more or be a little bit more inspired at the end of it. So we went ahead with it, and we thought we'd try and find the most awkward building on campus, which we did, which is Jewel House. So Jewel House has got an interesting background, so which the Dean mentioned earlier on. We have the building where Jewel did some, but not all of his work. And we have his name, and we have the grade 2 listing, and we have the blue plaque. The grade 2 listing made things very difficult. When you're trying to put air source heat pumps in, and boilers in, and batteries and PV, you start to begin to question why you aimed for a grade 2 listed building. But we got around it, and we encountered the same problems as other people would encounter, trying to put new tech into old buildings. So we set ourselves a realistic challenge, I guess. He created the unit of energy of the Joule. I'm not going to give you a lecture on physics, because that would be even more boring than this one. But we find his name on all the gas bills. Okay, we find his name embedded in some of the source code and firmware that Nick was referencing earlier on. Okay, so it's a good link, we think. It's very suitable for smart meter research, and there's also a small kind of energy. There's a research community in there of like-minded energy people, and there's a small kind of Joule museum in there as well to top it all off. Okay, so that's so I've addressed this in why we did it, where we did it, and I think the next one is kind of how we did it. So there's some booklets out on the tables that have all this information in. It's not the clearest set of slides. What we have in essence is we've got the smart meter systems, and we've got the smart devices systems. So on the left, we've got the smart meter infrastructure and the things that revolve around the smart energy infrastructure, so like battery storage, PV systems, EV. So in one room, we've got all the energy equipment, batteries, PV on the end of the building. A couple of batteries, Tesla and Duracell. We have obviously a full array of smart meters, SMETS 1, SMETS 2, live and head-end based that we can access and do things like change tariffs and automatic switching, everything else that you would expect from a full set of smart meters. And many of the people that have helped us with these pieces of equipment are in this room. Because you can't go and screw fix and buy a smart meter. And I don't think that will change anytime soon, but it's very difficult to build one of these labs, as we found out. And it's very difficult to get it all to work together as well. But we did it, and this is what we have. So we have the energy systems assembled around the smart energy network, if you like, on the left-hand side. So we've got heating, we've got combi boilers with gas, we've got air source heat pumps from NEBE, and they all drive the heating system in one distinct room in Dual House. The one distinct room is the smart home room, okay? And all that is a living room. It's a living room with a central heating system in that's distinct from the rest of the building, with smart home appliances in, smart TVs, smart speakers, smart blinds, anything that begins with the word smart, pretty much in that room. But it's all consumer stuff. And it's all stuff that, in theory, we should be able to map against, with, and alongside smart meter data. Okay? So that's our load on the smart meter data, on the smart meters, should I say. And it's also how we get the smart meter data out and into the living room. So do we put it on the TV? Do we put it on the PlayStation? Do we put it on the speakers? Do we put it on the Alexa show? Where do we put this data? And we also need something to drive the demand on the data. That's what it looks like. It's not too fancy, as you can see. It looks very similar to any test lab that you find, looking at gas meters, looking at electric meters, PV, batteries, etc., etc. The key is that they all work, they're all live, and we've got the contacts, the software, the firmware, and the equipment to do with these devices what we please, within reason. So whether they're live or whether they're based on a GFI system provided by Simon's team through the DCC. So we have a full kind of platform of things that you can play with, okay? I think I've called it in the past an adventure playground for smart meters. You can imagine such a miraculous place. So that's kind of what we got, okay? So it's different and distinct to the DCC lab, which I was talking to Simon about just before. And this is very much how we get smart things to talk to smart meters. Whereas the DCC might just be engaging with smart meters, this is how we take data sources and put them all together. It's about how we extract data from smart meters and how we can get smart meters to do interesting things with other things. So EV chargers, time of use tariffs round EV chargers is one thing we're looking at the moment. So there's a lot of things in there to kind of come and play with. And this isn't just for us. This is for, it's like the Energy House, the same business model. You come, you play, we help, you leave. Okay? You either leave with a product that's better, a product that may need some more work, or a product that's finished. This is the smart home side. So we also have a smart kitchen, which is further down the corridor on the same ring main. So we have the wireless attached appliances. We've got the Tesla batteries. We've got the BYD batteries. We've got Honeywell home systems for the heating side of things. Anything you can imagine, we have the smart kind of things around it. Okay? And then the idea is all of these devices can communicate with us. We can draw in the data and do something a bit more clever with it. Okay? So this is the kind of list of stuff that's in there. So we have separate electric and gas supplies, so we can totally split from the rest of that quite large building. SMETS 1, SMETS 2, gas, electric, CAD and IHD from most of the manufacturers, head-end access through Trilliant to make changes that are significant on the SMETS 1 side of things, add things to the HAN, remove things from the HAN, etc., etc., etc. And like I say, this has only been possible by people being very generous and kind. We have some DCC test comms hubs on the way. I won't say where they're from, but they're definitely on the way. We have SMETS 2 live installations ongoing. There's some glitches in the system. And none of this is as straightforward as it may seem. And we have virtual meters, we are with virtual hand and things like this, and test equipment to meet the DCC standards, so the GFI toolkit and things like this. And we also have PV on the building as well. PV, as I think it was either Peter or Simon mentioned earlier on, the import-export thing we think is more or less solved by the smart meter rollout. It's certainly a massive improvement to what we have, and there's certainly a lot more intelligence that we can draw from things like this now. So, you know, it opens up the doors to do a lot more stuff. We also have EV charging points. We have remotely managed batteries. We have locally managed batteries, gas combi, boilers, air source heat pumps, all the typical things one might find in a building. Full range of smart stuff as well. So, what are we going to do? We need some outputs. We only get money in the university by saying what we're going to do, so we have to be quite defined with our outputs. We believe that smart meter is a national infrastructure, and it's key. It absolutely is key. So, but we also think that when we treat it carefully and securely and with some knowledge, that there's loads of opportunities to innovate around. My talk, as you can see, is pretty, dare I say, not that very interesting, but the next talks that come from the guys that are innovating in this space, you will find exceptionally interesting, okay? And this is what we hope to open the door to, okay? So there's loads of stuff around hardware, the integration of heat, light, electric vehicles, PV, and storage. How do we get all those devices to talk together? It's very, very difficult. And anyone tells you they can get all these things working together at the moment, I probably would challenge them on it, particularly with the new infrastructures that are coming in. There's loads of stuff around software. There's loads of stuff around data analysis. How do we find out the characteristics of buildings? What do we do when we find out the characteristics of buildings? And how do we feed that back to get people to do stuff with their buildings? The same with energy switching and services. TOU, Phil is going to talk to you, I would have thought, quite at length about TOU from Octopus. They're one of the main innovators in the field. Charging, storage, electric heating all go hand in glove with time of use tariffs. And it's really, really technically complex to do any of this stuff. This young man that's just walked in with a cup of coffee here is one of our whiz kids that sits and makes all this stuff work, okay? It's a very, very, very technologically and complex problem. There's many people in this room that have been frustrated by smart meters. Hopefully, we're at the point now where some of those wrinkles might be ironed out, and we can really start to push on with some of this stuff. That's what this place is all about. So, what have we got on at the moment? Sorry. We've got a good number of projects on at the moment. We've got, and a lot of our project partners are in the room, as you would imagine. So we've got some non-domestic stuff. ND Semic. I won't pretend that I can remember the acronym. And that's working with Hildebrand. So Josh, who's going to speak later on, our side of this is using smart meter data to rationalise the energy performance and map out the energy efficiency of non-domestic buildings, which is exceptionally challenging. Disaggregation of appliances and things has been done by Hildebrand. Josh will talk to you about that. Prediction of faults, mapping of faults, and finding different things that might have gone wrong with the building fabric is the area at Salford are involved with. And obviously heat loss estimation. All from smart meter data with a limited number of other sensors. Okay, so loads of stuff we can do with quite high frequency data that's now kind of fully coming on board. I can remember this one. Home is a virtual energy network at Haven. So that's Honda, Good Energy, and Upside, and obviously us. And we're looking at how we use vehicle to home and vehicle to grid and a combination of the two to extract the maximum benefit from an EV battery. Okay, so you'll notice there's a large shed opposite this building with an EV parked in it. That's got a bi-directional charger. There's only one, I believe, of these type of chargers in Europe, which takes PV, the EV as an input, the grid as an input, and we can do anything we want with those energy sources. We can push it anywhere we want, to the house, to the grid, or to the car. And we can also do what we want with the battery in the car, push it to the house, push it to the grid, etc. So it's looking about the flexible energy systems. Really interesting project. TEEF, I think we're calling it, Thermal Energy Innovation Fund. That's Build Test Solutions we're working with. So, and Richard is going to present that later on, Richard Jack. So I won't steal any of his thunder, but working with Build Test Solutions, we're looking at developing solutions of how we can take the CAD, which we've spoke about at length, and use it to predict and inform the energy performance of buildings, but from a kind of a test-based solution. So this is maybe for building physics people who want to go in, designate the performance of a house, do something with it, and then kind of off we go with the changes that have been made. In essence, a live EPC. Okay. Working with Octopus, we're looking at HCalcs, so looking at feasibility and scope and exercise around time of use and EVs. Again, Phil's going to talk about that, so I won't take much of his time away. And something we've got upcoming is, and I'd like to just posit this idea while we're all here, is a hackathon. So one day, loads of data, smart meters being the central platform that we use, briefing at the start of the day about the APIs and the data that we can use. Home automation and heating controls will be present as well. Cash prize for the most innovative and useful solution produced on the day. And we welcome teams from academia and industry. And just drop me an email if you want to get involved with that. My email's at the end of these slides. I think I'd like to just say a massive thanks to everyone who's helped with the lab and the smart meter quest that we've been on, because it's been very, very tricky, okay? There's been a lot of people, I won't read them all out, but you can see who they are. And obviously our University Estates Department and everyone else for helping out. Also, thanks to the sponsors, because they've made all today happen. Vicky and Charlotte in the conference, and research teams, and Yanis and Alex and all the others in the team for helping out with the day-to-day work in the house and the lab. If you want to get involved, drop me an email or grab me outside. And that, as they say, is it. Has anyone got any questions?
Are there any questions for Richard?
It's Roland Hill from Landis & Gear.
Hi.
I didn't see any mention of human factors. Energy consumption is very dependent on attitudes of people, who's come to stay and such like.
Yeah.
Do you model all that?
You're absolutely right. We are not a human factors team, okay? We are a building physics team. However, we have people dotted around the room working our other teams. We're social scientists and human factors specialists. I think our goal, our remit, is to assemble data, analyze data, but we can't, and I'm first to admit this, be specialists at everything. Okay, so we hand it to our learned colleagues.
Any more questions?
So just to follow on from that, my name's Danielle and I represent some of those colleagues from the Social Science Department. So if there are other people in the room who are interested in the human-centred work that's going on with regards to energy, I'm guessing you can contact Richard and he will direct you to us. Okay.
I'll simply speak to Danielle in the break.
Okay, any more questions? Okay, thanks very much, Richard.
Thanks.